Hello. Today we will discuss about the solution of differential equations by using finite difference method. Actually, there are two types of differential equations available. One is known as ordinary differential equation and another is partial differential equation. So ordinary differential equation is the case when you have a function, say y function is there, and the variable is only one type of variable is there. So in this case, the ordinary differential equation will be applicable. So the differential equation in simple way, this can be written as dy dx. So one of the simple examples are the force, Newton force, the concept of velocity, and if you are considering the heat equation, so thermal conductivity, so heat flow, it's equal to thermal conductivity, cross-sectional area, and the temperature, now we can see it's a function of distance. Here temperature is function of distance x, here velocity is function of time, or here position is function of time. This gives you the rate of change of this thing, gives you the velocity. And there is another way, another type of differential equations are there. This is the partial differential equation. So here partial differential equation, your function f is the variables are not single. It's more than single. It may be more than one. It may be two. It may be three. It may be n in number. So when you have more than one variable, so the corresponding differential equation will be considered as a partial differential equation. So examples are the wave equation. Now we can see here the function y. It's a function of position and also time. Two variables are there. Okay, so now this side you have a variation with respect to x, and here we have variation with respect to time. So the Laplace equation, so the Laplace equation here, function u, it's a function of both x and y you are considering. So you are considering the rate of change with respect to x and also with respect to y. So in this case with respect to x and with respect to time. Okay, so both are considered. So you have ordinary differential equation and partial differential equation. So now you have to know how to find the solution numerically, how you can find the solution for this ordinary or partial differential equations. So one of the method which is known as the finite difference method, which helps us to find the solution for both ordinary differential equation and also for the partial differential equation. So to explain this one, I am considering a graphical representation of a function where y, which is function of x. So the nature of the function will depend which type of function you are taking. So here in this case the function nature is something like this. So here the value of x varies and the corresponding y value is also varies. Now the interval is a comma b. So within this interval you have this function. Now you need to find what is the differential equation, what is the solution of the differential equation. So to find the solution of the differential equation for the first order, so this can be considered as dy dx. This can be considered as y I plus 1 minus y I minus 1 and 2 of h. So what is this h? H is the distance between the x values. It starts from x0, x1, x2, x3 up to xn. So the gap between the two consecutive x values is h. So you have equal step size of h. Okay. So it starts with x0. Then if you add it plus h, this will give you x1. Now if you add x1 with h, this will give you what is called x2, and you can keep on continuing with this thing. So x0 will have a function value, say y0. When you are adding this thing, you will get another function value, say y1. Same way we can get another function value at y2. So this is represented over there. So now if you want to find the differential equation, the expression for the differential equation, this is given as yi plus 1 minus yi minus 1 divided by 2 of h. So here we are considering, say this particular point we are considering. So this point will be considered I plus 1 and this point will be considered as I minus 1. Obviously this distance is h and this distance is also h. So it becomes twice of h. So this is the solution for first order differential equation, a simple ordinary differential equation. Okay, here your function is only having a variable x. Now if you are considering the second order derivative, so for secondary derivative, now your equation is almost similar. Now here we need to consider y I plus 1, I minus 1 and the ith one. Now we do this written as I plus 1 means this one, minus 2yi, obviously the center one is considered as ith one. With respect to this we are calculating, and I minus 1, obviously the I minus 1 is the earlier one, okay, and the h is becomes h square divided by h square of this one. So actually we are finding the second order derivative of the first order derivative of these two section and first order derivative of these two section. So I and I plus 1 and I and I minus 1. So when you are finding the difference, you will get the second order derivative. Now in case of partial differential equation, so the problem is a little bit of complicated. If the number of variable increases, so the complication will increase. But in general way, so there are two types of variable partial differential equations are available. Although more number of variable partial differential equation with number of variable is also available. Now to solve this problem, so here what we have considered a single line. Okay, so we can consider a single line. Somewhere here you have I, and then you will have the I minus 1, and you can get you can get this is I plus 1, and this can be considered as I minus 1. Okay, because we have a single variable. But if you have another variable, so this can be represented graphically by some other line. So obviously the center one, even this is 1. Say now, just let me just write it. So this is I, okay, for this particular axis. Now if you are considering this particular axis, our values can be considered as this is j. So this point is considered as j. Now we can consider the next point. So next point is considered as j plus 1, and the earlier one will be considered as j minus 1. So you have two variables where iterations are represented at I and j. But when we have an ordinary differential equation, we have only I over this. Now see, this is represented by this particular. So you have one point somewhere here, there will be next point and the earlier point. And same way, this is along the vertical direction also, horizontal and the vertical direction. We have two variables. So you have considered the case, say our function is a variable of x and t, or if you have u as a function of x and y, some two values we are considering. So in one direction you have variation of x, another direction you have variation of y for the case of u function. And if you are considering y function, now here you have one variation along x axis I, another variation is along x axis, along j axis t. So the equations can be written as du dx. That means here you have x plus h comma y. That means here we are considering u I plus 1 and y will be considered as that ith one. And again you are considering this is I minus 1. So this is I plus 1, and this is considered as I minus 1 and divided by twice of h. Same thing if you are only considering the variation along x axis. So y will also be considered as a constant one. But in the second case, here you can see you are considering the function, the u function, which is a function of x and y. Now we are considering the variation along y. So here you can see x will be taken as constant, y plus h, minus ux is taken as constant, y minus plus h and minus h. So this is represented at ux and uy. Now in this case we have only variation along x and y. Okay, so one is constant, another will be taken as a variable. But it may happen that simultaneously both are changing, both x and y are changing. For a particular function u, both are changing. So now how to represent this one? So now this will be represented by this type of expression. Okay. So here we have both x and y variation. So now we are considering x variation, second order x variation. Now we have a second order y variation. Now the problems are similar. Here you have I, and here you have I plus 1. Okay, and this is I minus 1. Correct? Okay. Now in this case y was taken as constant, x was variable. Now in this case x was taken as constant, y was considered as variable. So this is written as x and this is written as y. So two variables are here, second order variables. So 2 times x is varying, 2 times y is varying. Now in this case, okay, obviously this is the expression which is given over there, just I plus 1, j constant, I minus 1, j constant. And the second case, what you have considered, ij you have considered. So I taken as constant, j plus 1, here I taken as constant, j minus 1. So I have this expression. So if you are rearranging this one, so at any point the variable I and j will be expressed by this particular function. So y, actually this will be 8 square. This will be 8 square obviously. Now how to represent it? How to represent it? Obviously we need to consider a two-dimensional space where we can consider a variation along x and y. So we are considering function u. Okay, here x and y is variable, both are variable. In one direction x is changing and another direction y is changing. Now if you want to find, say, this particular point you want to find, so for that case what you have to consider, you need to consider the next point and the earlier point, okay, for I-axis. And same way for the y-axis, for the j-axis or y-axis, one can consider, you need to consider the next point and the earlier point. So j plus 1, j minus 1, I plus 1, I minus 1, and this is the ith point and the j point. Now you can consider, when you have a grid type of thing, it's a rectangular system. So this rectangular section is basically surrounded by, say, any point you are considering. So the nearest point in this case, there will be 1, 2, 3, 4, 5, 6, 7, 8. So any single point is surrounded by that 8 points. So all the 8 points if you are considering, so your problem will be very, very complicated. So there are two ways to solve this thing. One, either you can consider the standard method or you can consider the diagonal method. So what is a diagonal method? First consider the diagonal method. So diagonal method, for this particular point, we will going to consider the diagonal points. This point, this point, this point, and this particular point. We will going to consider all these 4 points, the values of these 4 points. Okay. Now we need to find the average of this one. So what is the formula? Formula is 1 by 8 square, and we need to consider all the diagonal values plus all the diagonal values, this and this 4 diagonal values. Okay, and there is another method where we can consider the standard one. The standard one is considered as, say, we can consider another 4 points. What are those 4 points? These 4 points, I'm taking it by blue color. This point, this point, this point, and this particular point. Same way, the relation will be 1 by 8 square, and you have the addition of all the 4 points. Okay. So these are the diagram, which is one is explaining the diagonal method, another is explaining the standard method of calculation. So this is known as the 5-point calculation. Why 5 point? So with respect to 1 point, we are considering all the 4 points. So this is 4 plus 1, total 5 points was considered. So 5-point calculation it's considered. So this is the diagonal way to explain this one, and this is the standard 5-point formula we are considering. So in this case, diagonal points are considered, and here the other points, other midpoints was considered. Now come to the numerical problems. So here you have a differential equation, second order derivative of y, x plus y. Now here you have a function, say function y is equal to f of x. It's a single variable, okay, and the boundary conditions for x equal to 0, y is equal to 1, and x equal to 1, y is equal to 1. H value given as 0.5. So in simple way, one can consider a system something like this. At the center, I is 0, and here we can consider I plus 1, and this can be considered as I minus 1. Okay, so 1 and minus 1. So what are the values? So one can just think about, say this is x0, this is x1, and this is x2. So if this is x0 means this is the value is 0 here. Then the step size is 0.5. So if you add 0.5, so this will become 0.5. And the next point is 0.5 plus 0.5, this is equal to 1. So now these two values are given. So in this formula, the y value at that point and at that point, this is given. You need to find the solution for this particular case. Okay. So straightforward way, the problem, the second order derivative can be represented by this y I minus 1 minus 2yi plus 2yi plus 1 divided by 1 by h square. As this is 0.5, h is 0.5, so 1 by h square, this is becomes 4. So now we can just write this thing. So obviously you have one x and y, so this is xi and yi, this is equal to 1. So what is x and y? So one can just think about along one axis you have a x variation and another axis you have y variation. Okay, so you are just moving along the x points. I need to calculate what are the corresponding y values. Got it? Now put I is equal to 1. So if you put I is equal to 1, what it comes? It becomes I, if this is 1, so 1 minus 1, this becomes 0. This is 1, this is 2, this is 1, 1. Now put these values, which values are known to you, put these values. If you are putting these values, because you know y is 0, the first value is this is equal to 1. If you put this 1, if you simplify all this thing, your equation becomes something like this. Now in next step, you can put I is equal to 2. If you put I is equal to 2, again you can get a simplified expression, something like this. Now you have some of the values, you have the two extreme values. So obviously when you have two extreme values, you can calculate. Okay, you have only, just let me just drop this section. Okay, you have this point and this point. Okay, you need to calculate the other values. So if you put I is equal to 1, I is equal to 2, and you will get two equations over there. Okay, you will get two equations over there. So put these values in this expression, and you need to solve this linear equation to get the value of y from this thing. Now we have two equations, solve these things, we have two variables and we have two equations. So if you solve this problem, obviously you will get the values of y1 and y2 from this. Now a simple graphical representation is given over there. So x value is given, corresponding y value is given. Okay, so we need to calculate what is the standard value of this one. Okay, so you get. So find the solution somewhere at x equal to 3. So if you want a higher accuracy, obviously you can go for the higher accuracy of this. Same type of problem. Okay, so you have a second order derivative x plus y. So earlier case this is x into y plus 1, x into y plus 1. Now you have second order derivative, this is equal to x plus y. Same type of problem is there. You can just consider, put the boundary conditions. Okay, put the expressions in this form. Y I minus 1 minus 2i plus y I minus 1 xi plus yi. Put these values. Now we have three cases. I 1, 2, 3. Put these values. We have three equations. Okay. Now put the boundary conditions. You will have some simplified form of this equation. Now you need to solve this thing. Okay. So when you are solving this one, you can use the matrix method. You can use any of the method by which one can solve the linear equation. They are basically in the form of a linear equation. So you can solve this linear equation. Here I have solved it by the matrix method. You are considering the rows and columns. Okay, so you can consider the rows and columns. You can consider the element values over there, corresponding element values. Okay, and here you have a y1, y2, and y3. Okay, and this is equal to the values of 0.25, 0.5, and 0.75. These values are there. So by using the matrix method, rearranging the rows and columns, you can get the values of y1, y2, and y3. So from this differential equation, you can get the points over there. Okay, so you can solve this thing. Now again, we have this graphical representation: x0, x1, x2, x3, x4, and the corresponding y value. So from first and the second one, you are able to calculate that other. So these two values are given and you will be able to calculate other points from this. Now come another problem. Same way we can have this thing, write the differential equation first in a ith form, in a iteration form, then put the values I, 1, 2, 3. Okay, so get the expression, get the linear expressions, put the boundary conditions and solve it by using your known methods, known technique. Now these are the ordinary differential equation. So consider a case of a partial differential equation. So you are having a function which is a function u. It's a both variable of x and y. Okay, and the conditions are given. Just see, the conditions are given. The graphical representation is already given over there. So what is this? So u1, u2, u3 and u4. Okay, the next values are given over there. This is 500, earlier one was 200. These are the 1000 values. These are the 1000, 500, 00. These conditions are given. So for any particular system, the surrounding values are known. You need to know that u1, u2, u3 and u4 values. Okay, so in the earlier problem, what you have considered, you have this type of problem. You know that two extreme points. Now in between points you are able to calculate it down. So here also you know the surrounding points you need to calculate this. So how to calculate? So we need to consider the variation along I direction. You need to consider the variation along Z direction. That's mean J direction. So one direction is I, another direction is Z. You need to consider this. Just remember this formula. So this is 1 by h square. So h value is given as 0.5. So you are considering this is 1 by 4. Okay. So now you need to consider the surrounding points. So either you can go for the diagonal points. Remember, we have just mentioned this thing, the diagonal points you can consider, or you can consider the standard points. Okay, standard midpoints you can consider. Which method is favorable to you? Which method seems is easier to you? You can use this particular technique. So get the expression, put the given values, and you can go for the successive iterations. So iteration means I1, I2, I3. We can go for this one. So for each and every time, as we are considering the diagonal or the standard method, finally you will get the solution for u1, u2, u3 and u4. So what are those? u1, u2, u3 and u4. Now the most important part about this numerical method is that if you go for small number of iteration, so obviously in number of cases you will not get a very high accuracy. But if you are going for large number, a sufficiently large number of iteration, you will get a higher accuracy in this case. But every time if you go for, it's not a directly proportional thing, that if you are going for very high number of iterations, accuracy will be very high. There will be some limitation. But obviously, if you go for sufficiently higher number of iteration, you will get sufficiently higher accuracy. So in this case, if you keep on increasing the iteration, so it starts with 1, so you can see the suffix 1 is there. You can go for suffix 2, you can go for suffix 3, so more accuracy will come. And finally, up to the 8th iteration, you have a very accurate calculations. Okay, so this is the idea about the finite difference method. So in case of finite difference method, you are able to solve the ordinary differential equation and partial difference equation by using this formula, by using the iteration formula. So what we are considering the earlier point and the next point along I direction, along Z direction. And then by using simple numerical, linear equation problem, one can solve this thing. Okay, thank you.